Here is a system of equations. Our goal here is to find out what number x and y would have to be so that both of these equations are true. Let's look one equation at a time. This equation has a solution when x equals 2 and y equals 1. Where did I get that? Random numbers. Don't worry about it right now. Watch this. If I replace x with 2 and y with 1, and I do PEMDAS, I get a true statement. 4 plus 1 does equal 5. Thus proving that 2, 1 is a solution to that equation. Now, I'm just showing you that equations right now can have many solutions, so let's find another one. What if x is 3 and y is -1? Where did I get that? Don't worry about it. It works. Watch. If I replace x with 3 and y with -1, and I do PEMDAS, I get a true statement. 6 plus -1 is 5, thus proving that 3, -1 is a solution. Here's another solution to that equation. I could show you the work, but the main point here is that if you take any one equation with an x and a y in it, there's almost always going to be an infinite number of solutions to that. I've listed 3 of them here, but there's more that I could list if I wanted to take the time. Now, let's consider the second equation. Remember, there were 2 of them. This equation has this as a solution, this one, and many, many more. And I'm not going to show the work, but here's the point. We're looking for a single-ordered pair that works for both. Oh, look, there is a single-ordered pair that works for both. And therefore, 3, 1, 3, -1 is a solution to this system of equations. Now, what you just saw is a bunch of guessing and trial and error and just seeing what worked. And that's not the most efficient way to go about solving a system of equations. So while I've convinced you, hopefully, that 3, -1 is a solution to both of these, I want to show you the actual algebra strategy that you might go through to solve a problem like this. I want to start with something called the addition or elimination method. Here's a system of equations. Remember, our goal is to find out what number x and what number y could be to make both of these equations true. What I'm going to do is I'm going to add both equations together. Before I do, notice if I add the equations together, the -2y and the +2y cancel each other out. The x and the 7x add up to 8x, and I add the numbers on the right. And what I've done is I've eliminated a variable, which is why this is sometimes called the elimination method. We don't have the letter y anymore. Now I can just divide both sides by 8, and I know what x is. Well, knowing what x is only half of what we wanted to know. So let's take one of our original equations, substitute x equals 4 into that equation, and try to find out what y is, which we can do with some very simple algebra. Subtract 4 from both sides, divide by -2, and I now know what number y has to be. Well, I've gone through all that algebra to find out that x and y are these particular numbers, and therefore this ordered pair is my solution to the original equations, which you'll see here. There's the answer. Let's take a look at another system of equations and use the addition-elimination method. First of all, notice if I were to add these equations right now, the x's wouldn't cancel, nor would the y's. Adding these equations together right now is not a great idea. So what I'm going to do is I'm going to multiply the top equation by 2. Now, I know what you're thinking. Why on earth would you multiply by 2? Well, it isn't always going to be 2. But you have to kind of think, what am I going to get to do to cancel something out? Notice, because I chose 2, if I then take the other equation and I add it to the result of what I got when I multiplied by 2, the x's are going to cancel. So your goal on these problems is to think of a multiplier that you could multiply one equation by so that it would cause a cancellation when you added it to the other equation. And now that the x's cancel, I can divide both sides by 7, and I know what y is. Now that I know what y is, I can take the original equation, one of them anyways, plug y equals 5 into it, and just do basic algebra. Subtract 5 from both sides, divide by -3, and I now know what x is. In fact, I now know what x and y both are. So I have found the ordered pair that that satisfies the original problem. Here's the original problem, and here's its solution. Now let's take a look at a different solving technique called substitution. Here's a system of equations. Notice the top equation is already solved for one of the variables. So I can take the second equation and substitute in what that is. Notice I've replaced y with 4x minus 1 because according to the original equation, y equals 4x minus 1. Now I can just do some basic algebra. Notice I distributed the negative sign here, or the subtraction. Now subtracting 1 from both sides and simplifying will tell me what x is. Remember, I want to know what x and y are, so knowing x is only half of the battle. Now that I know what x is, I can take x equals 2 and substitute it into the original equation, or one of them anyways, do some math and find out that y is 7. Now that I know x is 2 and y is 7, I have the ordered pair that satisfies the original equation.